Hey guys, it's me, Miss Mills, and welcome to Miss Mills' Math Time. The whole point of this video is to help you out with reflections on a coordinate plane. This is, again, it's not exactly notes, it's not exactly worksheet, it's going to be a little bit in between. I'm going to introduce you to reflections on a coordinate plane. I'm going to do a lot of examples on here, but some of the slides are going to be up to you to completing them. So this homework is going to be worth not 20 points like a note. It's not going to be worth like 40 points for a homework. It's going to be worth about 30 points, okay? Where 20 points is going to be you doing the notes with me, and the last 10 points are going to be you doing the work yourself, okay? So that's how this is going to be graded. I'll tell you what slides you need to be doing yourself and things like that. So just pay attention and you should be good to go. But I need to go ahead and introduce you to reflections. So we talked about translations already. Translations is where you just moved the figure from point A to point B. I kind of introduced to you what translations were in the last video. I just talked about how you would describe moving a figure using translation. You would tell me it would move like so many times to the left or to the right, and then you would explain to me how many times it moved up or down and things like that. And when you move a figure using translation, you have to move all of the vertices, a part of that figure, to move it correctly, okay? You have to move everything to move the whole figure. Reflections are going to be a little bit similar, but you'll see the difference in reflections and translations as I talk about it on here. So let's go ahead and get started then. So a reflection flips a figure over a line. It's called a line. It's called a line of reflection, and I'm going to go ahead and highlight that in order to create a mirror image. Okay, so reflections, again, they're like mirrors or looking at your self in a reflection in a pond, or I'm using the inverted filter on your TikTok, stuff like that, where you kind of flip the image or flip the figure in this case. For this notes on this slide in particular, this image, my example image, is flipped over the y-axis because this is our y-axis, this is our x-axis. The figure is flipped over the y-axis. Therefore, the y-axis in this case is the line of reflection, okay? And again, it's used to create a mirror image. As you can see, it's not just moved across the axis, it is flipped across the axis, as you can see. So that's what we're going to be doing. Each point on the figure should be the same distance away from the line of reflection on the opposite side. So for example, as you can see, like if we use this point and then its sister point over here, again, they should be the same distance from the line of reflection. So this is our line of reflection, and let's see if they're the same distance. In this case, if we're looking at our first image, it is 2 points away from the y-axis, where over here it's 2 points away from the y-axis, okay? So all of the points are going to be just like that, where all the points are the same distance away from the point of reflection, and that's how you're going to be solving these, all right? Okay. All right, let's talk about the different types of reflections. Again, the line of reflection can change. Like in our first example here, this is my hot air balloon, and the hot air balloon is getting reflected over this axis right here. It's getting a mirrored image on the other side. This would have a line of reflection on the x-axis, okay? Where this one over here, the hot air balloon is getting reflected over the y-axis, just like in our other example, okay? So I just wanted you to know the difference between flipping over the x-axis and flipping over the y-axis. And you'll start seeing a trend from moving something over the y-axis as you would the x-axis, okay? All right, so let's practice, and this time we're going to do an example reflecting the figure over the y-axis, okay? And we're going to record the pre-image and the image. I already recorded the pre-image coordinates for you because I'm nice, so we're just going to focus on the image afterwards. And remember, the difference between the pre-image and the image is the little apostrophe that's behind all of the vertice labels. So this would be called a prime, because that apostrophe is called a prime. B prime, and then C prime. So this would be our image. This is after we moved it, okay? This one would be our pre-image. This is before we move it, okay? Alrighty, cool. Okay, let's get started. So if we're looking at coordinate A, we need to see what the coordinates for A prime is going to be. All right, so we're reflecting it over the y-axis. Let's see what the coordinates are. Because for A, it is 7 and 4. So let's see what the difference is. So in this case, A, here's the coordinate right here. It is on the x-axis, because the x-axis is first. It's at -1, -2, -3, -4, -5, -6, -7. Yeah, that's about where it's at. It's about -7. And on the y-axis, it is at 1, 2, 3, 4. It's at +4. Okay. All right. Now let's look at our B prime. Our B prime is on the y-axis. Or on the x-axis. It's at -1, -2. Okay. -2. And then on the y-axis, it's at +1, 2, 3, 4, 5, 6. It's at +6. And then for C prime, again, we're going to do the same thing. On the x-axis, it's at -1, -2. And then on the y-axis, it is at +1 and then +2. It's about at +2. Okay. They're not exact, but that's because it's hard to make things exact on this. So I'm sorry about that. But it's pretty much exact. So here's our things. And now we need to notice, what pattern have we found? Okay, so what did we find on this? Well, as you can see, as when the figure was flipped over the y-axis, the x value in our coordinate plane, or on our coordinates, became the opposite. Okay, so this went from a +7 to a -7, a +2 to a -2, a +2 to a -2, but our y value stayed the same. So I'm going to write that out real quick. The x values flipped signs, or you can say became the opposite, something like that. Flipped signs, while the y values stayed the same. And I'm going to go ahead and tell y'all guys, that is going to be the case every single time you flip a figure over the y-axis, okay? Every time you use reflection, the x values are always going to flip from a +2 to negative, or -2 to positive, or vice versa, right? The y value is always going to stay the same, because you remember, when we flip it over the x-axis, that does change, but on the y-axis, it still stays the same, going up or down. Okay, so the x-axis, or the x values, are going to flip signs, while the y values are going to stay the same. And then it says, how can we represent it algebraically? There was an exact way on how to do that. Let me see. Oops, no, stop. Just move up a little bit. All right, can you represent it algebraically? And yes, we can. We're going to say that our x-axis is going to flip, okay? And I'm going to say that by a -x, okay? And then the y value is going to stay the exact same. So that's how you can represent it algebraically. All right, so just make sure you know, when flipped over the y-axis, the x value is going to flip signs. The y value is going to stay the exact same. So if that's the case for the y-axis, the x-axis is, as you could probably tell, is going to be the complete opposite. The y values are going to flip, but the x values are going to stay the exact same. So let's prove that real quick. Here's another example where instead of flipping the figure over the y-axis, now our line of reflection is our x-axis right here. So let's go ahead and test our theory. Okay. All right, so here is our pre-image, and then we flip it over. The x-axis here is our image. Now let's check. I already recorded the coordinates of the pre-image because I'm nice, so we're only going to find the coordinates of the image itself. So let's go ahead and do that. Not click, I'm going to do focus. All right, so let's first focus on A. So we're going to look up the coordinates of A prime. As you can see, A is 2 and -2. I bet A prime is going to be -2 and 2, but let's check. All right. Or it's going to be 2 and +2. Okay, so let's check. All right, so A prime on the x-axis is at +2. We're right so far. And then on the y-axis, it is also at +2. Nice. All right. So now let's check our B prime. If the pattern still holds, that means this should be 7 and then positive 7. So let's check our theory. B prime's right here, so let's count. On the x-axis, it's at 1, 2, 3, 4, 5, 6, 7. About at 7. Good, good, good. All right. So let's check our y-axis now. We're going to go up 1, 2, 3, 4, 5, 6, 7. Again, it's about at 7. Awesome. So yeah, we're still doing good so far. And according to this, our C prime should be positive 2 and then positive 7. So let's check. On the x-axis, again, it is actually, yeah, it's at positive 2. And on the y-axis, it is at 1, 2, 3, 4, 5, 6, 7, positive 7. So we are good. So it says, what is the pattern we found? Well, it's the opposite of the last one. The y value is going to flip the sign, or you can say is the opposite, while the x value is going to stay the same. And to represent it algebraically, we're going to say the x value stays the same, but the y value is going to switch the sign. Okay, so that's what I want you to write down there. Okay, so only thing I want you to do is I want you to do this slide right here, okay? So here's our pre-image. You're going to tell me what the coordinate's going to be when reflected over the x-axis. So remember, on the x-axis, you know, the x value is going to stay the same, but the y value is going to flip the sign, all right? And then you're going to tell me what it's going to look like when reflected over the y-axis. Again, we proved this. The y-axis, where the x is going to flip and the y is going to stay the same. So what you're going to do is, here's your pre-images. You're going to tell me what the coordinate would be if it reflected over the x-axis, and then you have to tell me what the coordinate would be when reflected over the y-axis, and then I want you to summarize what happens to the coordinates when that happens. So guys, if y'all have any questions about reflections, let me know. I hope y'all have a wonderful weekend, and I will make videos for y'all this week. All right, I'll see y'all later. Let me know if you have any questions. Bye.